Hi there, this is Ryan Orsinger with a quick intro on working with lists of dictionaries in Python. Okay, so lists are pretty straightforward. We have lists in real life. We have lists of chores, we have lists of favorite bands, and those things on the lists are in order, right? That's all a list is in Python, is a list of, just like we talk about in real life, right? So we can have a list of numbers. We can have a list of strings. In fact, we can have a list of lists. And we can also have lists of dictionaries, right? Dictionaries are a little different. Rather than using a numeric index and rather than relying on order, dictionaries are a data type that allow us to access values by a corresponding key. And that key is a label. So think of dictionaries as labeled lists. One place where you can immediately see an example of a dictionary type of data type in real life is nutritional facts on the side of a box of crackers or something like that, right? So lists of dictionaries are incredibly common in Python and in other languages, and they are incredibly common because when we talk about database tables or spreadsheets of information, those are often represented as lists of dictionaries because we have lists of lists. And that's all a list of dictionaries is a list of labeled lists. So let's get started with this. This first cell of code in this notebook is a list of dictionary objects in here. So the data type of the variable list is list, because we've got square brackets, but each and every item of this list is a dictionary. Notice all of these dictionaries have the same exact keys: type, calories, number consumed, whether or not they're caffeinated. Okay? On the right-hand side of each one of these properties, we have the corresponding value, like water, orange juice, or the number of calories, and the specific value. So keys are the labels, values are the values. That's it. So while we can... Well, a lot of tutorials will introduce lists and then introduce dictionaries. It's usually on the shoulders of the learner to figure out how to work with these things together. And so this example and this walkthrough is here to help you. Okay? So let's take a look at this first exercise. How many different kinds of drinks are represented? Well, that's pretty easy. 1, 2, 3, 4, 5. Okay. But that's not the point of learning a programming language. Like, what if we had a list of drinks and we didn't know how long the list was, or the list was hundreds of different items, or thousands? We wouldn't want to count those manually. The idea with programming languages is we have the programming languages do things programmatically for us. So thinking about this one, we could probably say, hey, for every drink in our list of drinks, we could maybe have a counter that we set to 0, and then we can increment that counter by 1 every time through, and then we can say print number of drinks is, and we can print that right out, and that's going to be the counter. So our loop loops through the first time through the loop. The first item, we count this item, then we count the second item, the second time through the loop, third time through the loop, we count the third item, yada, yada, yada. So let's run that cell. All right. Something that always happens with programming is mistakes and bugs. And there are two types of bugs in the world. There's things you can learn from doing something incorrectly, learn from the bug, or we have a typographical error. Looks like in this place we have a typographical error. I have a variable called counter that I set to 0, then I'm modifying a variable called count. Well, each variable points to a different spot in memory, so we need to make sure that they point to the same spot in memory. So we have 5 different beverages. Okay? Another programmatic way of solving exercise number 1 for exercise 1 here would be to programmatically count the number of items on a list. Lists are so common that we don't need to make a for loop with a counter every time we need to count the number of things that are on a list. We can use the length function. len is a length function. It's built into Python, and then we can provide the name or the variable of collection, in this case, this list. And we see that the length of the drinks list is 5. So there's 5 different dictionaries in this list, okay? Again, we always want to have the code doing things for us, okay? Let's move on to the second exercise. How many total consumed drinks? Well, this is a little bit different of a question. When we look at each different type of drink, there's a key called number consumed. So if we look at this and did this manually, this would be 7 plus 4 plus 1 plus 2 cappuccinos plus 3 hot teas, whatever that value ends up being. I guess that's under 20, right? So 7 plus 4 is 11, 12, 13, 14, 15, 16, 17, okay? But we don't want to calculate things manually. Okay, let's move on to exercise 2. How many total consumed drinks? Okay, so if we were to do this manually, we would go up to each and every drink. We'd take 7 plus 4 orange juices consumed, plus this 1 Gatorade, so that's 12 different beverages consumed. 2 cappuccinos makes 14 beverages, and then 3 hot teas, that makes 17 beverages consumed. Pretty easily manually if you only have 5 things on your list like this, right? But here's what we need to do. We're going to need to hop into this and we'll say for every drink in our list of drinks, we'll make a happy little for loop here. What we can do is add the number consumed of each drink type to a running total. Okay, and we can make a running total up here. We can say total drinks consumed, and we'll start that at 0. And then every time through the loop, we're going to take a look at, we're going to say that total drinks consumed will be what that total drinks consumed used to be, right? Plus another value. This other value will be the number consumed. And let's crank this out. Total drinks consumed. All right. You'll also see the syntax here when we're saying the new value for a variable is defined by what that variable used to be plus some value. There's a shortcut for writing the same thing where we're updating a value, and it's with this syntax here, total drinks consumed. So we put our variable name on the left, plus equals is shorthand for saying make sure that the new value of this variable is what it used to be plus this new value. We'll run the code again, we get the same exact answer. So you're going to see that a lot. Okay? All right. There is another way of writing some syntax to calculate the same thing. We can use the sum function. And usually the sum function works with a list of numbers, and it works very well. But what we're going to do here is we're going to sum up values in this dictionary by their key. And I'll show you what I mean. So instead of this simple sum of 1, 2, 3, we're going to do sum. We're going to sum the drink number consumed, for each drink in our list of drinks. This should be 17. There we go. Because when we're accessing each dictionary, we're accessing the value behind the key. How do we get our hands on one single dictionary at a time? Well, the variable drink is created by the for loop for drink and drinks. We could do for car in cars if we were working on a list of cars, right? For people, for person in people, or something like that, right? Always for singular and plural, so we can operate on the singular thing inside the loop. Okay? All right. Let's keep going. So exercise 3, how many total calories consumed? Multiply each drink's calories by the total consumed. So if we drink 7 waters or 100 waters, our total calories for water should be 0, right? And how many total consumed calories? So total consumed calories would be 0 times 7 plus 220 times 4, because we had 4 orange juices, plus 140 calories on Gatorade times 1, right? So the drink calories times the drink's number consumed for each and every dictionary. So let's do that. If we were to say, so let's see, for drink and drinks, we'll set that up, and let's make our little counter total calories. We'll zero that out. And every time through the loop, what we're going to say is our total calories goes up by the drink number consumed times the drink calories. And then we can print this out. Total calories, and let's run it. There we go. That is not a well-balanced diet if that's all consumed by one person in one day, right? See how we're multiplying each drink type, number consumed of that drink type, by the number of calories, summing that all together to add to the total calories, right? Cool. Let's keep going. How many types of drinks are caffeinated? Okay, so we can eyeball this real quick, but again, programming languages mean we're doing something programmatically, so we need a nice way of filtering through things. So what we could do, we could say types of caffeinated drinks and zero that out. It's very common practice. It's called an accumulator or a rolling total. Think of it like a tab. And we can say for drink and drinks, well, what are we going to do here? If the drink type is caffeinated, we're going to increase that counter by 1. So eyeballing this, we know that there are 2. 2 is the right answer, 2 caffeinated drinks. But how can we filter inside of a loop? The answer is with a conditional. We say if the drink type, or if the drink caffeinated is true, then conduct the following operation. So our key is caffeinated. The values are either true or false. So we're saying if the drink, each drink is caffeinated, then we're going to take our types of caffeinated drinks and increment it by 1. And then the cool part is, well, yeah, this is going to show us the number 2. The cool part is that this code here, with the condition inside the loop, with the appending here, or with the incrementing the number by 1, this can work if you have 1,000 things on this list, or 1,000,000 or 1,000,000,000 things on this list. Billions and billions of items on lists, right? Programming languages work on lists all the time. So let's keep this going. How many total consumed drinks were non-caffeinated? Okay, well, this is a little different. We're going to look for non-caffeinated drinks. And we're not looking at the drink types. We're looking at the total number consumed. So let's look at the data. Let's go back, look at the data. The non-caffeinated, so water's non-caffeinated. This would be 7 plus 4 plus 1. And then that's it. So this would be, let's see, 11, 12 should be our answer here, because that's the total number of beverages without caffeine that we consumed here. So let's roll this out. Total consumed drinks. Total consumed non-caffeinated drinks. Always make your variables very clear, so you never wonder what X means or Y or Z means. And then we're going to do a happy little for loop for each drink in our list of drinks. We will say if our drink caffeinated value is false. If this is a non-caffeinated beverage, then what we're going to do is take that total consumed non-caffeinated drinks and increment it, not by 1, because that's counting the types, but by the number of each drink's number consumed. Because we had 7 beverages of water, 4 orange juices, etc. So this should be a much higher number than 2. And let's output our total consumed non-caffeinated drinks. There we go. 12. That's what we counted out manually before, right?